So this video is about forces, and it's really important to understand forces because they affect our paper planes just as well as the real planes. When we think about forces, we want to think about it in two different ways. There's contact forces, which are easy to understand. You know, they're things actually, you can see the force being applied. And then there's non-contact forces. They're sort of the harder ones, the invisible ones, which we talk a lot about lift and, you know, gravity and things that are not so apparent. But the main four forces, what are they, James?
Lift, drag, thrust and weight. So I think thrust is one we should talk about first because the energy we put from our arm into our paper plane to get it flying. And so to maintain that momentum, we need to make our planes nice and sleek and aerodynamic so they cut through the air and reduce drag. So maintaining that thrust is really important.
And so for thrust is really interesting because thrust isn't just about going fast, it's about thinking about the speed at which your plane flies. And there's lots of different planes around the world all doing different things. And so when we go to throw our planes, we like everyone to think about the speed that plane comes out of your arm and the way that you throw that plane. So thrust is the first one. We want to have our planes moving forwards at least.
So for instance, Dylan's plane has lots of weight in the nose and that helps carry the momentum forward from the front. So if you think about it in terms of when you throw a dart at a dartboard, you have the weight in the nose and then you have the fletchings at the back that kind of create the drag to keep the pointed part of that dart facing forward. And so with thrust, it's really important to maintain that inertia, that weight in the nose of the plane to keep it carrying forwards.
But then we move on to gravity and we talk about gravity being the anti-force, the one that stops us flying. It keeps us nailed to the ground, it pulls everything down. No matter what, when you release something in the air, that thing is going to come back down to the earth. And so for us, we need to find other forces, ways of folding our planes, and we need to think about our throwing techniques to keep our planes off the ground. For us, it's about the shape of our wings and the angle of our wings on our paper planes. And so we like to talk about all the different variables when it comes to how our wings are designed on our paper planes.
So Dylan just touched on the angle of our wings, and that's called the angle of attack. So that's how the wing faces into the wind. So it's really important that we get that right in our paper plane so that the function of lift happens correctly. But that angle, it also has to be folded symmetrically. So the force of drag affects both wings equally. And so when we're doing a lot of our planes, you really have to think about symmetry and alignment and taking care to be nice and accurate so you get a really good result with your plane.
We talk about drag as a really annoying force, but it's also a really helpful one. Drag is kind of about the stickiness the air creates against the surface of our plane. You know, it slows us down. So if you imagine riding your bike really, really fast, you feel that air pressing against you. So when our planes are flying through the air, the same thing's happening. The more force we exert on our plane, the faster it's going, the more air is pushing back against that plane. So we think about the shape of our plane, we think about the shape of our wings, and we also think about sort of techniques that we can use to harness how drag works to make our plane steer and change direction.
Yeah, so and part of that too with drag is about the paper weight. So there's lots of different types of paper and different materials that you can experiment with your plane. So for instance, a lighter GSM paper, around 50 GSM, that's grams per square meter, means that it has less weight or inertia to push through that air around it. Sometimes that's called the Reynolds number, so it's really worth looking that up. But this is standard copy 80 GSM paper, so it's a bit heavier. It has a bit more inertia or kind of momentum once you've thrown the plane, and so it'll have a greater speed but won't fly as slowly through the air. And so if you want to be a time aloft thrower like me, you might want to consider using lighter paper weights so that your plane sails on the wind a bit slower. So the last one, of course, the most famous force of all, it's the most complicated force, and there's a lot going on. It's more than just like 3 or 4 things happening, is lift.
So lift for us is about how we get our plane flying through the air with air rushing over the top and underneath our wings. Air rushing over the top of our wings, if we shape our wings in the right way, we get that airfoil shape. It means that we have a difference in pressure over the top and underneath our wing. For most planes, the curvy shape of our wing means that there's a really low pressure system on top of that that air. And air hugging that sort of shape of that, that wing is really important. Air going underneath the wing, because the wings are generally flatter underneath, it's a very different speed of air. And so when we've got a difference in pressure, we always like to say that the high pressure air underneath the wing tries to get into the space of the low pressure air above the wing, but the wing's in the way, it's going to push against the wing. There's more to it when we think about the angle of our wing is a really important part to lift, but generally we want to make sure that that air is helping us to generate that upwards pressure.
So Dylan's kind of briefly touched on a few different laws or forces, and so when a plane is in contact with the air, particularly those early RAAF box kites, the air was rushing towards the wing and kind of pushing them up to the air, so the equal and opposite reaction. So that's Newton's third law. Now, he also touched on Bernoulli principle of difference of air pressure creating lift, but there's also the Coanda effect. So Dylan also talked about the curve of that wing. So when air travels over that wing, that Coanda effect means that air is flung downwards beyond the trailing edge of a wing, and that helps kick the plane up forward. So there's more than just a few different forces or scientific principles that are acting on our plane to create this magic of flight called lift, and it's really exciting to explore some of those different scientific theories and how they all come together in a really complex way to make essentially what is a paper object, a metal object, kind of seem to defy gravity.
So you can put all of those amazing forces to action, not just in the real planes we see behind us, but your paper planes as well. And so we're going to show you today the F111.
This is the F111. It's one of my favourite planes. The reason I like it so much is that it's angular and sleek, but it's got some really nice delta wings swept back. You just got to fold this and fly it, and you'll know what I mean, why you'll love it so much. So to start this fold, we're going to grab an A4 sheet of 80 GSM paper. I'm going to use green today, and we're going to fold it in half lengthways. Lots of our planes start off with this fold. It kind of sets the backbone. Once we've done that, we open it back out and we fold into the center using the crease as a guide. Now, as we're folding planes, you can use a bone folder. It stops the oils from your fingers getting into the paper and makes your creases nice and crisp. So folding down into the middle, again using that center crease as a guide. Just fold up next to that crease, don't fold over it. This just helps the plane come together a lot easier towards the end. So now we've got a really sharp delta wing. Once we've got that, we're going to fold it down to the bottom. So folding that down to the bottom, again lining up that center crease. So then what we do is we fold again the top wings into the center. So you can see what I've done there. We're going to do the same thing to both sides. It's really important with planes that we try and make things nice and symmetrical and even, because that means the force of drag affects both wings equally. So there's the finished product there. Now, what we've got to do is unfurl that nose and make it point forward. So folding that back over the top, making sure those creases run parallel in line with each other, and we'll end up with something that looks a bit like this. All right, now we want to fold it in half, making sure all of those folds are hidden on the inside. And now we come to the angle of attack, which is really important. I'm going to grab a pen and I'm going to mark it on so that you can see where I want you to put this fold. So the angle of attack is really important for lift because it makes sure the wings are facing into the wind at the right angle to perform that magical function of lift with those forces. Now I've just drawn it roughly on there, but you can see how it tapers forward at the front and higher at the back. So I'll fold that wing down, and that gives me a template to match the other side too. So I'm going to take this other wing and fold it down, lining up all of those corners and points. It's a lot easier to do this on a table when you're folding. Helps you make the creases nice and accurate. Now the last thing we do with our planes is we add what's called dihedral. It's this Y shape. And what that does is that when we let go of the plane, it's going to open out, isn't it? So we've got to make sure that is expressed quite strongly so that when we do let go of our plane, we have this very nice, subtle dihedral angle. It keeps the plane nice and stable in the air if it encounters some turbulence. So there it is, the F111. I can't believe I'm doing it here with the plane behind me. How cool is that? So first things first is you test your plane out, make sure it's flying well. Usually it's okay, especially after the first fold and the plane is fresh, but sometimes you need to add some tweaks to your planes or trimming. So the first thing you can do if your plane is diving, you can give it a tiny pinch at the back, and I'll show you what that looks like. So if we're pinching it up, we're just doing a tiny pinch towards the center of the plane. It's ever so slight, it's almost unnoticeable. That helps the plane, it gives the plane an elevator that pushes the back down and lifts the nose up into the air. The next thing you want to check is just make sure that you always maintain that nice dihedral angle so that when your plane is flying and it opens out, there's still a little bit of a Y shape, a very shallow bowl in those wings. It's time to see how this flies.